Hello everybody. Today we're going to be reviewing another Riemann sums problem, except this time we're going to do left endpoints, right endpoints, and add in midpoints. So our first question is approximate the area between the graph y equals 4 minus x squared and the x-axis on the interval of -2 to 2 using n equals 4. Once again, we have our formula and a reminder that n refers to the number of rectangles. So first we want to start by finding the change in x. So we have 2 minus -2 over 4, which becomes 2 plus 2, which is 4 over 4, which is equal to 1. So our delta x is equal to 1. So when we're doing our left endpoints, we're going to do area is equal to 1 times f of, and to determine what numbers again we're going to use for those 4 rectangles, we want to go back to our number line. So here's our number line. We have -2, -1, 0, 1, and 2. Once again, that's 5 numbers, and we only want 4 rectangles. So we're going to take the 4 leftmost points, which would be -2, -1, 0, and 1. So we want to do area is equal to 1 times f of -2 plus f of -1 plus f of 0 plus f of 1. So what that is going to look like is area is equal to 1 times 4 minus -2 squared plus 4 minus -1 squared plus 4 minus 0 squared plus 4 minus 1 squared. So what that's going to come out to is 1 times 0 plus 3 plus 4 plus 3. So area in this case is equal to 1 times 10, so area is equal to 10 for our left endpoints. So we're going to go to the next page and do the right endpoints. So once again, we want to start with that number line, plotting our points. So we have -2, -1, 0, 1, and 2. Except this time, we want to take for right endpoints the 4 rightmost points. So 2, 1, 0, and -1. Once again, we've actually computed the values for -1, 0, and 1 in the previous left endpoints. So what our area is going to look like is area is equal to delta x, which was 1, times f of -1 plus f of 0 plus f of 1 plus f of 2. So like I said before, we already did some of this work, so it's going to be 3 plus 4 plus 3 plus 4 minus 2 squared. So what that is going to look like is area is equal to 1 times 10. So area is equal to 10 for the right endpoints. So actually what happened here is that the approximations were the same for both the left and the right. That's not super common, but it does happen sometimes. What we want to also do is incorporate the midpoint, which is going to be a little bit different. So let's go to another page. So in this case, we want to create our same number line. So we're going to do something a little bit different this time. So when we have the midpoints, we still only want to use 4 rectangles, but what we're actually going to do now is take the midpoint between all of these numbers. So what that is going to look like is this is going to be -1.5, this is going to be -1/2, this is going to be +0.5, and +1.5. So if we take the midpoint between all the 5 numbers we were given, we actually only get 4. So we're going to use those 4 numbers to plug in for x. So what that's going to look like is area is equal to delta x, which once again was 1. And then do f of -3/2 plus f of -0.5 plus f of 1/2 plus f of 3/2, and then compute from there. So we're going to do area is equal to 1 times 4 minus -1.5 squared plus 4 minus -0.5 squared plus 4 minus 1/2 squared plus 4 minus 3/2. What happened here? 3/2 squared. So that is going to come out to 7/4 plus 15/4 plus 15/4 plus 7/4. So if we compute that, we're going to have areas equal to 1, and this all actually comes out to 11. So area is equal to 11 using midpoints. So I do want to note that there are other possibilities for Riemann sums. You can actually compute the area under the curve using rectangles. You can do Riemann sums using limits, although I wouldn't recommend it. And also you can have your delta x be something else other than 1. So